Good evening. So, I told you guys that I wanted to do a recording for the problems to finish up on this section so you guys are aware of how to do those. So, let's go ahead and deal with it while we're here. First things first. We need to understand horizontal asymptotes. We understand vertical asymptotes. So, before I talk about that, let's understand the vertical asymptote here. Now, your vertical asymptote, hold on. Your vertical asymptote is just going to be, being that this is our domain is all values of x such that x does not equal 3, then our vertical asymptote is just x equals 3. That means that's the line that our graph cannot touch. So, let's see. I'll draw the vertical asymptote right here. So we have that as our vertical asymptote. Now, horizontal asymptotes, to actually find that, if the degree of the numerator is equal to the degree of the denominator, then our horizontal asymptote y is just going to be the ratio of the leading coefficients. So notice here in this function, the degree of the numerator is 1, the degree of the denominator is 1. So since the degrees are the same, then that means that it's going to be the ratio of the leading coefficients. Leading coefficient here is 2, leading coefficient here is 1. So that means that our horizontal asymptote is just going to be y equals 2. So I'll just put that, our horizontal asymptote is just going to be y equals 2. And I'll draw that, which is going to be here. Like so. And since we have those, so we have both of those things going on, and that's what we're going to base our graph off of. So since we have those drawn, let's talk about points that are on the left and the right of the asymptote that we have. So since it's x equals 3, then let's talk about the points that are on the left of it. In other words, less than 3. We'll end up with these points right here for negative 2, negative 1, all the way to 2. All right, so that gives us some points to plot. Next, if we look at points on the right side of 3, which is x is greater than 3, then we're talking about these points. So once we have all those points plotted, we should end up with a graph like that. Notice how this graph approaches the asymptotes but never really touches them. So that's the idea of how to graph it if in fact you have a binomial on the top and a binomial on the bottom.